Good morning again, OChem 2. I am so excited. In this video, let's try a different type of problem. Let's do one of our fill-in-the-blank problems. Let's see if we can recognize what kind of chemistry we've got going on here and go one step backwards. It's really helpful for synthesis. I love fill-in-the-blank questions. I almost always have one on the exam, and that just really gets you in your groove for going one step backwards. I love it. So remember from our last video, synthesis, I love numbering, especially in this unit. It's going to help us piece together what kind of reactions we're looking at. In this case, right away, look at that 1, 2, 3. What does that tell us? That screams some version of our aldol reaction. And from our last video, this was a nitrogen. This one is an alcohol. So this is awesome because this is just our standard straight up aldol. In fact, when we look at our reaction conditions and we see base, this is a directed aldol. So then our job is to figure out in our directed aldol what our starting materials are. What's the order? Let's see if we can recognize everything. I love the aldol backwards because we already know exactly what bond is making and breaking, and that is between 2 and 3. Always. That's what your aldol does. So that's the bond that you break. And then holy crap, look at this part right there, number 3. That is that. Remember, in your directed aldol, you actually make the enolate first. You make your 1, 2 first. So let's, for funsies, just draw what that would look like then. You make this with your base. And then you're adding that electrophile that's given. This is your number 1, 2, and 3. Now, I kind of see a mistake in this question. Does anybody picture that yet? Look at that base I'm using. Is that the right base to make this enolate? In fact, it isn't. So you could totally, oh, this is a sparkle pen. You could totally correct me on that. What would be the better base to use for that? LDA. Okay. All right, awesome. So then what does that really look like? That means your starting material is that ketone. And here's your 1, 2, 3. Okay, perfect. I love it. All right, what about this next one? This is actually a reaction we haven't done yet. What you're doing is adding something to this carbon. That is a conjugate addition. For us, every practice test will be a little bit different. For us, 1,4 additions are in our next unit. They are coming, in fact, later this week. They're one of my favorites. They make our aldol even more useful. So that is on our next test. Okay. So let's scroll down a little bit. Oh, this one looks promising. This looks fun. All right, now we're going forward. We have a ketone and a secondary amine. All right, that should be straight off your cheat sheet, right in your notes whenever we're mixing a ketone and a secondary amine. Let's draw the intermediate just so we can kind of see if that's the end-all be-all or if we need to monkey with that. We're going to form the imine. Now, in this case, why did I draw the intermediate? Because you would get to this iminium ion if you draw that mechanism. Can we leave it like that? No, in fact, this is going to form the enamine. So our stable form of that product then is going to be the enamine. Okay, and then let's take a look at this bottom one. Ooh, how fun. We are going from a ketone to a double bond. There is only one reaction that does that, and it is my favorite to say. That is our favorite German reaction with phosphorus. That is our Wittig. So you want that on your cheat sheet for sure. That is on this test. And how do we do that? Remember our shortcut in class, we cut right here and we cut right there. And so what would our actual Wittig look like then? Well, let's count our carbons. We've got a 3-carbon unit there. So how do you make the Wittig happen, though? It's one thing to recognize the Wittig, it's another to write out those reaction conditions. So Wittig always starts with an alkyl halide. Why did I choose number 2? That's where we're forming our bond. And then you treat it with triphenyl phosphorus and then N-butylate. Remember, you have to make that ylide. You have to make the Wittig ylide that would end up looking like that. Okay. All right, wasn't that fun? All right, I'm gonna stop and then we'll do another video for another question, just in case my videos aren't saving because they're getting too big. So let me stop here and post this one, and then I'll have another